Go outside on a dark autumn night, away from city lights, and look up. If you know where to look, you can see it with your naked eye, a small, faint smudge of light. That smudge is the Andromeda galaxy, a trillion stars, 2.5 million light-years away. It is the most distant thing a human eye can see. The light hitting your eye left Andromeda before humans existed, and while that light traveled, the galaxy that sent it has been doing something you should probably know about. It has been coming straight at us at 400,000 kilometers per hour. For 100 years, science has told a single story about how this ends: collision. Our galaxy and Andromeda, fated to smash together and destroy each other's spiral forms forever. Your galaxy's death, scheduled and certain. Then in June of 2025, a team of astronomers published a paper that stunned the field. They reran our galaxy's future 100,000 times, and the certain collision became a coin flip. This is the story of how our galaxy got a stay of execution. To understand why this matters, you have to understand that a century ago, we didn't even know Andromeda was a galaxy. Most astronomers thought our Milky Way was the entire universe, and Andromeda was just a small glowing cloud inside it. In 1920, the two biggest names in American astronomy held a formal public debate about it in Washington. One argued the Milky Way was everything. The other argued those spiral smudges were island universes impossibly far away. The audience went home without a verdict because nobody had a measurement. 3 years later, one photograph ended the argument. In 1923, at the Mount Wilson Observatory in California, Edwin Hubble photographed Andromeda through the largest telescope on Earth and found a single flickering star that changed everything. A star whose pulses revealed its true distance, roughly 1 million light-years, far, far outside our galaxy. You can still see the exact moment it happened. On the glass plate from October 1923, Hubble first marked his new dot with an N for nova. Then he checked older plates, realized what he was truly looking at, crossed out the N and wrote 3 letters in red ink, VAR, a variable star. That crossed out letter is the instant the universe became 1 billion times bigger. The trick behind it belonged to a woman named Henrietta Leavitt, who had discovered years earlier that certain pulsing stars tick like calibrated clocks, time their pulse, and you know their true brightness, and from that, their distance. She was a human computer at Harvard, paid about 30 cents an hour. Her ruler measured the universe. That one measurement shattered the universe open. Andromeda wasn't a cloud, it was an entire other galaxy, an island universe of its own, and the cosmos was suddenly filled with billions more. But there was a twist. Years earlier, an astronomer named Vesto Slipher had split Andromeda's light apart and noticed something odd. Nearly every galaxy's light is stretched red, fleeing away from us as the universe expands. Andromeda's light was compressed blue. It is one of the very few galaxies in the sky moving toward us. And Andromeda is not a fair fight. It spans more of your sky than 6 full moons side by side. If your eyes could gather all its light, it would be the most spectacular thing in the night sky. It may hold 1 trillion stars to our few 100 billion. The thing coming toward us is bigger than we are. 110 kilometers closer every single second. Do the math across billions of years and you get a prediction: contact. So what does it actually look like when two giant galaxies collide? Not what you'd think. Stars are so absurdly far apart that virtually none of them will ever touch. If the sun were a grape in Maryland, the nearest star would be a grape in California. Galaxies pass through each other like ghosts. But the gas collides. Vast clouds of hydrogen slam together and ignite firestorms of star birth, millions of new suns flaring to life at once. Night skies across both galaxies would blaze with newborn blue stars and glowing pink nebulae. Gravity would fling entire spiral arms across space like spilled paint. The show would unfold in slow motion across 2 billion years. First, Andromeda swells in the night sky decade by decade, century by century, until it stops being a smudge and becomes a structure. A second Milky Way rising over the mountains. Every generation inherits a bigger one. On the first pass, the galaxies swing through each other and rip glowing streamers of stars across the dark. Then gravity hauls them back for a second pass, then a third, each encounter closer, until the two cores finally surrender and spiral together. And at the center, the two supermassive black holes, ours 4 million suns, theirs perhaps 100 million or more, would spiral together and merge, unleashing gravitational waves and lighting up as a quasar, the last great fireworks show. Simulations even track our own sun through the wreck. In most runs, the solar system survives. Remember, stars almost never collide, but gets flung outward, tens of thousands of light-years from the new galaxy's heart. relocated to the distant suburbs of the merger with a front-row view of the aftermath. When it's over after a billion years of chaos, the tangled wreckage settles into something new, one colossal, calm, golden elliptical galaxy. Astronomers even named it in advance Milkomda, both spirals gone. That was the accepted obituary for the Milky Way. Written, dated, filed. In 2012, it looked like the case had closed for good. Hubble finally measured Andromeda's sideways drift, and NASA announced a head-on collision, guaranteed in about 4 billion years. Artists' impressions of the doomed sky went out worldwide. Textbooks were updated. The obituary ran. Then came better data. A European spacecraft called Gaia spent a decade measuring the positions and motions of nearly 2 billion stars with insane precision, refining that sideways drift to a level that borders on absurd. Watching Andromeda move across the sky is like watching a human hair grow from the distance of the moon. In 2025, a team led by astronomer Til Sawala fed everything into the models, 22 variables, every major galaxy in our neighborhood, and ran 100,000 simulations of the next 10 billion years. The result, published in Nature Astronomy, carried a title that says it all: No Certainty of a Milky Way and Andromeda Collision. The number came out almost exactly 50-50. Half the simulated futures, collision and merger. The other half, the two galaxies swing past each other like ships in the night, close, gravitationally entangled, but never merging. Our galaxy's fate is quite literally a coin toss. And the deciding vote belongs to a galaxy most people have never thought about, the Large Magellanic Cloud, a bright little companion visible from the southern hemisphere. It's only about 15% of the Milky Way's mass, but its gravitational tug on us is enough to pull our trajectory sideways, away from a head-on hit. The run of the neighborhood may save the Milky Way. Even in the futures where the collision happens, it's been pushed back from 4 or 5 billion years to 8 or 10. The apocalypse didn't just become optional, it got postponed. Here's the uncomfortable footnote, though. None of us were ever going to see it anyway. In about 5 billion years, our own sun will swell into a red giant hundreds of times its current size, boiling the oceans and quite possibly swallowing the Earth whole. Our star dies before the galaxies ever meet. And long before Andromeda arrives, the Large Magellanic Cloud itself is expected to spiral in and merge with the Milky Way. A smaller collision, a couple of billion years out, that's far more certain. Our galaxy will be changed regardless. The universe does not do permanence. And one more twist while we're revising fates. Whatever happens with Andromeda, dark energy is quietly carrying every other galaxy in the universe beyond our reach. Billions of years from now, the merged giant or the Milky Way alone will hang in an empty sky. Astronomers born in that era will look out and see nothing but their own stars. They may never know other galaxies existed. We live in the brief age when the universe can still be read. But step back, and the real story of this episode isn't about collisions at all. It's about what science looks like when it's working. A century of textbooks said inevitable. Better data arrived, someone reran the numbers honestly, and inevitable became 50-50. The authors themselves put it perfectly. Proclamations of our galaxy's coming demise, they wrote, appear greatly exaggerated. The universe keeps its options open. So next autumn night, find that faint smudge above the trees and look at it. A trillion stars rushing toward you at 400,000 kilometers an hour, and even the people who know it best cannot tell you how the story ends. Next time we come home, almost, because the biggest question in science might have just been answered by a robot, alone in a dried-up riverbed on Mars. In 2025, it drilled into a strange spotted rock, and what it found passed a year of the most brutal scientific review on Earth. The strongest hint of life beyond Earth ever found is sitting inside a sealed titanium tube on the Martian surface right now, waiting for a ride home. That story is next.